In any case, whichever problem we are addressing or dealing with, we have to be able to encode different solutions, potential solutions to our problem, and we have to be able to evaluate them. In all the cases, the objective function would be a function like this one, subject to some constraints. For instance, in the case of the knapsack, if your solution has the form of a binary array, then this function is the sum of the profits times if this object is in the knapsack or it is not. And the constraint is that the sum of the weights of the objects should be less than or equal to the capacity of the knapsack. Well, the space of potential solutions will depend on the problem. For instance, in the case of the knapsack, it is a binary space, which is obviously the discrete and countable and so on. In the TSP is also discrete, etc. So in the knapsack problem, your solutions take the form of binary arrays. So we call this binary encoding, which produces as many as 2 to n potential solutions. In this case, well, I said that the evaluation function is the sum of profits. Sorry. And the constraint is that the sum of the weights must be less than or equal to the capacity of the knapsack. In case we were dealing with the TSP problem, then our solutions will look like permutations. Something like this. So we call this permutation base or order base encoding. The number of possible solutions is n factorial. If this is your solution and you are provided with the adjacency matrix, which tells you the distance from CTI to CTJ, then your function is the sum of the distances of the ith city to the following one, plus the way back. In case you are dealing with other problems, such as this one, for instance, in this case, you are given a set of objects with individual profits and also profits which are profits that depend on the combinations of objects. So here you got a profit matrix, and this is Pij, which is the profit that you obtain if you put the objects I and J into the same knapsack, because you got several knapsabs. So your solutions will look like something like this. This means that the first object is put into the first knapsab. The second object is not put into any knapsab. The third object is put into the same knapsab as the first object, and so on. So this is integer encoding, integer encoding. In this case, the number of potential solution is the number of knapsabs, k plus 1, powered to the number of objects. The fitness function is that the sum of the paired profits should be maximized. You are summing these profits if the knapsack where you have put the ith object is the same as the knapsack where you have put the jth knapsack. And they should be larger than 0. Well, something like this. But also you have to satisfy that for every knapsack, the sum of the weights of the knapsack must be less than or equal to the capacity of the knapsack. In case you are designing controllers, then your solution will look like programs. There are many programs, different programs, with a limit in the number of instructions in these programs. I'm not going into details here, but in order to represent these programs into computers, we are going to use trees. We are going to speak about these problems in much more degree later, in about the middle of the semester. So the main the main encoding schemes are binary encoding, permutation base, integer, programs, and there is also another one which is real parameter. Real parameter. In this case, you are provided with a function. This x would look like something like this. 1.2, 3.01, and so on. So real parameter variables. The purpose of the evaluation function is to evaluate the solutions, to assess the quality of the solutions, which means that they are going to guide the algorithm.